Hello and welcome everybody. My name is Pablo Moreno. I'm part of the Metabolomics team here at the EBI, the European Bioinformatics Institute. Today I'll be giving a brief overview of our project PhenoMeNal, which is about bringing metabolomics data analysis to the cloud. And then after that I'll do a walk through some of our resources which you can already use to try to experiment what would be your data analysis experience on the cloud. So very briefly, our consortium is formed out of 14 partners. We are for a 3-year project that got funding for 8 million euros to fund 841 person months. PhenoMeNal is part of the Horizon 2020 Societal Challenge in Health, Demographic Change and Well-being, and is led by EMBL-EBI. And you can see some of the partners in the map there scattered through Europe. The main idea behind PhenoMeNal is to try to bring metabolomics data analysis to the cloud. So what we see currently is that researchers in metabolomics today use local premises to do their metabolomics data analysis. So they might be used to use certain metabolomics data analysis bioinformatics tools that they are used to, certain maybe even workflow environments to use these tools, access certain public and private data, but all running either on computers on their lab or maybe a local cluster at the local university or research institution. The problem that this constrains is that when you are running this type of analysis, you of course need to have plenty of analysis tools installed in those machines. And many times the installation and setup of those tools is relatively complex for most researchers. There's also a well-known lack of bioinformatics manpower in the metabolomics data analysis field. And also another problem that that many researchers have is that when they are running analysis on a particular cohort size and then they come to the next project that has a larger cohort, a larger data set to analyze, it's difficult for them to migrate all of this installed software that it's available for them locally in their local cluster or computers at their lab to a larger infrastructure because they need to do all of the reinstallation of software and pipelines, etc. Because of this is what we propose is to be able to take that very same analysis that many of you might be doing in your local premises, in your local cluster, to a cloud environment. And the idea is that you'll be able to use the same metabolomics data analysis tools, access the same type of public and reference data, access as well your own private data, and even workflow analysis tools to facilitate the use of these tools. So the idea of what PhenoMeNal provides, it's an infrastructure that very quickly will lift everything so that you have all your tools, workflow environments, access to data in the cloud on a particular cloud provider of your choice. Then you are able to run your analysis and then bring everything down. And then this can be replicated many, many times on different setups. So this means that taking your analysis to a larger scale is much more easier now because taking all the analysis tools, it becomes easier. So in order to be able to achieve this, in PhenoMeNal we have developed a number of components. So the first one, which is the PhenoMeNal Cloud Research Environment portal, which is available at the URL that you see there. This is the first point of access for external users to our resources, and it's the place where a user would go and trigger the creation or the deployment of a small PhenoMeNal cluster for that user in a cloud provider. In order to be able to do that, we have encoded all of the infrastructure that will be created in a cloud provider in what is called infrastructure as code. So all the settings of the machine sizes, the amount of RAM that they will have, the amount of disk, but also the software that is running on top of them, how they communicate as a cluster, the ability to run containers, etc. So we codify all the infrastructure so they can be very quickly lifted and then brought down. In order for analysis tools to run on top of that infrastructure, we have been working with tool makers, with tool providers, to create and isolate tools in what you call software containers. This is a key piece of our architecture in the sense that it allows us to guarantee reproducibility throughout time, because each of the tools is packaged in this manner and is left completely stored and versioned in a way that it can be reused later on without much problems. And then to be able to analyze data with those tools on top of that infrastructure, we have been working as well with data producers to package or provide ways of packaging data so that they can be uploaded to these instances and be analyzed with those containers that we provide for the tools. So in order to explain how all of these elements work together, I will explain now our main use case for a researcher. So imagine that you have a researcher in metabolomics that has credentials for a cloud provider, in this case Amazon Web Services. The idea is that this user would come to our cloud research environment portal and it will request the execution of the deployment of a PhenoMeNal cloud research environment on the cloud provider. When this happens, the cloud research environment portal will take this infrastructure as code and will deploy for the user and privately for the user what we call a PhenoMeNal cloud research environment on the cloud provider of choice. So this essentially is a small cluster of computers that it's dedicated only to the user, that will have all the metabolomics tools that we can provide currently, so that this user then can go and actually do some actual research work. And for that, we provide workflow environment tools, graphical workflow environment tools that will allow the user to interact with the different tools without having to have any programmatic or Linux knowledge, but only the ability to understand which tools he needs to use and then use them through a friendly user interface. So as the user starts to interact with this workflow environment and triggers the execution of different tools and workflows, then the containers for those tools get pulled into the cloud research environment and the jobs take place, and then the user can see the result of the different executions of different tools on top of his own data. So what is exactly a PhenoMeNal cloud research environment? From an architectural point of view, it has a number of layers and it's a relatively complex product if you want. So we start from hardware at the bottom, or infrastructure as a service, and this is provided by, say, Google Cloud Platform or Amazon Web Services, or OpenStack, which is a flavor of a private cloud installation that many institutions today provide to their users. So it might be the case that your university can provide you with an OpenStack account, for instance. And then on top of that, we deploy a set of machines that will become our cluster in the longer term. And on top of that, we have a number of layers that allow us to work with containers, so the container engine and a container orchestrator. And on top of this orchestrator, which is nothing but a cluster of computers for use with containers, is that we can deploy our workflow environments and the different tools that we have. And all of these makes up what we call the PhenoMeNal Cloud Research environment, which again is nothing but a small cluster where you can run all of your works. This is provisioned using industry standard and open source tools, so you can rest assured that the software is pretty robust and the infrastructure is pretty robust to be able to use and secure as well. However, we don't intend you to have to deal with any of the technical complication of the multiple layers that I explained before. What you would see as a user in the end after a deployment is nothing but a workflow environment, in this case Galaxy, which will allow you to drag and drop these little boxes, which will represent each a tool that needs to run on certain input. And each of these tools, as I said, they are backed by a container. So what will happen is that as you run this workflow, and each of your tools are backed by a container, as the workflow starts to run, the different containers get dispatched into this infrastructure that is running on the back. And as the workflow progresses, more and more of these things will get to run on the back with containers, but with you not having to sort of be aware of any of these details. So this is how it works essentially. You get a workflow environment, you can execute your different tools and workflows there, and this automatically gets deployed into this larger cluster that is behind. Let me remind you that when you do a cloud deployment, this is your very own cluster, so you're not competing for resources with other users, as it normally happens when you're using a shared cluster. In terms of availability of tools, currently we have 158 modules for this workflow environment called Galaxy. 97 of them are part of a suite called OpenMS. Out of these, we have 7 modules for NMR. We have 26 additional modules to mass spec besides the 97 ones that OpenMS has. We have 14 modules for data transfer and data packaging using ISA as well. And we have some modules for statistics as well. And all of these modules are backed by 53 containers that take care of packaging the tools in a reproducible way. One of our workflows allows, for instance, to do a carbon-13 trace-based Fluxomics. So it will essentially take data stored in NetCDF from LCMS, plus some definition of a model in terms of an SVML input. An SVML input is a sort of a specification to store a pathway, if you want. So different small molecules and reactions that are interacting. Some constraints that are proper to this experiment, and then some layouting to be able to draw a final result in the form of a pathway. And so when these inputs get added into the instance, then a first tool called Ramit can take them, extract them. The following tool, Midcore, corrects for isotopolog abundances, and then the last tool will fit these abundances into a pathway model like the one shown there through flux balance analysis based methods. This is work mostly done with our partners at the University of Barcelona in the group of Professor Marta Cascante. Another example of workflow that we have is an MS1 Metric Workflow. So in this workflow, you can use tools like XCMS and Camera to be able to get to some level of identification of small molecules in mass spectrometry. And this is developed by our partners at the IPB Halle Institute, led by Stefan Neumann. We have a further MS1 MS2 tandem MS2 workflow for analysis of mass spectra, which is a lot more complex, and it allows you to interchange components from the XCMS suite of tools for MS and the OpenMS package. So it's very nice because you can choose certain steps of the workflow and exchange them between the two platforms in case you would have preference for some algorithms or the other. This is a joint work between our collaborators at the University of Uppsala, led by Ola Spurt and Kim Kultima, and Stefan Neumann again at IPB Halle. We have a prototype 1D NMR workflow as well, where we expect very soon to be able to add an interactive module in which you'll be able to do interactive base correction and other fitting of the 1D NMR data. And this has been done with a number of people that are outside of the PhenoMeNal community, which have an interest in this seeing done, like Daniel Cañueto, Daniel Jacobs, and Anna Marku from outside the consortium, and led by Reza Salek and Christian Peters within our consortium. We have a workflow for statistical analysis as well, which you can use downstream your NMR or MS analysis. In this case, it's shown doing a reanalysis of some data that can be downloaded from the metabolites resource here at the EBI. This workflow essentially will do univariate data analysis, then step into the multivariate data analysis, and allow you finally to do some classification to produce some very nice figures that allow you to further inspect relevant discriminators within your data sets. And this is mostly developed by our collaborators in SIA in Paris by the group of Etienne Tevenot. So as I mentioned before, the main entry point for users to be able to trigger the deployment of a PhenoMeNal Cloud Research Environment is the PhenoMeNal Cloud Research Environment portal, available in the URL that you can see here to the left. The Cloud Research Environment portal has gone through 3 usability rounds. We value a lot that our users can find what they need to find, and that they can make the most of the architecture design. So we take a lot of care into that. It's the portal that allows you to do cloud deployment to the different providers. It also allows you to get access to a public instance, a test drive instance, where you can get a feel of how it would look inside a deployed instance on the cloud without having to deploy yet. A showcase of all of our tools in the app library, and documentation both for end users and developers who might have an interest in bringing their tools into PhenoMeNal. And most of this is developed by my colleague at the EBI, Dr. Sijin He. As I mentioned before, the CRE portal, which takes care of the deployment, currently allows to deploy a PhenoMeNal Cloud Research Environment to OpenStack, which is a private cloud installation environment, which it might already be available at your university, and it will probably mean that you can do deployments without having to pay a cloud provider, or to public cloud providers like Amazon Web Services or Google Cloud Platform. Of course, the use of Amazon Web Services or Google Cloud Platform means that you need to pay for the resources that you use. This is something, of course, between you and the cloud provider, between Amazon and you, or between you and Google. We don't take any part in the financial transaction. The only thing that you do is that you come with your credentials for those services, and you use your credentials to deploy an instance with the facilities that we provide. So now I will do a walkthrough of the portal, and then I'll show how to do a deployment from the portal on Amazon Web Services. So I will switch now to my web browser. So here you can see the PhenoMeNal portal. As you can see, we have a first part where you can go and create your cloud research environment, where you can go and test drive our cloud research environment in a previously deployed instance. So I'll click here to see where you go, show you where you go. This takes us to our public PhenoMeNal instance, which is very much and very similar to what you would get if you would deploy on your own. I will come back to this later because I want to start a deployment that takes a little while. We have here the app library as well, and I will showcase after deployment and documentation and tutorials. So I will start by trying to create a cloud research environment. So I will press create cloud research environment here. Because I haven't logged in, this will ask me to log in. We are currently using the Elixir single sign-on mechanism so that you don't need to create any additional accounts. So I'll press here on Elixir single sign-on. This will take me to some web pages from Elixir. So with Elixir single sign-on, you can sign on using different providers like Google, LinkedIn, or Orchid. You can also use your institutional account. So for instance, you could search for University of Cambridge, for instance, if you have an account there, or you could search, I could search for EMBL-EBI, and I can log in with my EBI credentials. For this particular example, I will just log in with my Google account. So it asks me to choose my account. It recognizes my profile from my account. Now, because I previously deployed something to show you, I get to see this screen before. So this is an example of a previously deployed instance. But I will go now to how it looks when you would get if you wouldn't have anything deployed previously. So I pressed here and create it now. And here is the screen that I showed you before. On this screen, I can get an account to the public instance that I previously showed. So if I would go here and do a logout, and then to be able to log in, I need some credentials. You can get those credentials by pressing register here, and it will ask you to enter your email and create a password, and then that will give you access to the public instance. Or, as I said, you could deploy to a private OpenStack or public web services like Amazon and Google Cloud. So I will show you now how to deploy to Amazon. It's relatively simple. We press here select on Amazon. We need to define the region in the world where we want to deploy in Amazon. So I will choose Ireland for this example. Then I need to add my credentials for Amazon. In order for you to know how to get your credentials from Amazon, if you have an account, we provide some documentation which you can follow. So these tutorials will show you how to get the details that you need to input in the following screens. And now I will add my access key then and my secret access key to start the deployment. Press next now. Because we create a cluster for you, we need to set up some credentials so that cluster is secured only for your own usage. So for that, this will ask me to add an email. So that's here, and a password for that instance, and confirm the password. And with that, we press next, and this will now ask me to confirm the details, and I will press deploy now. So the process of deployment, it's a complex one, and so it takes from 15 to 20 minutes to run, roughly. So in the meantime, I will show you around the portal in the other places, and then we will come back to the result of this deployment. So we'll go back to the main page of the PhenoMeNal portal. So as I previously mentioned, if you press here, you will go to the public instance, for which you can get a login through the create your cloud research environment that I mentioned before. On the shared instance, you would see exactly the same things that you would see on a deployment. So you could find all of our tools for transfer, for Fluxomics, for NMR, for statistics, for mass spectra analysis. Here we have plenty of tools. Tools from our partners, from Workflow for Metabolomics, which is another initiative which tries to bring metabolomics data analysis into Galaxy, not into the cloud, but into Galaxy, but we collaborate with them. Some post-processing tools and tools for data packaging through ISA. Additionally, you will find that, well, if I log in here, I can show you existing workflows. So if I go to workflow here, well, possibly the best thing would be to go to the shared workflows. So here are the shared workflows that you will normally find in any deployed instance, the Fluxomics workflows, NMR 1D, Fluxomics with visualization, W4M statistical module, and Metabolomics with the camera and MedFrag. So now I'll go back to the portal to show you other bits of it. So we covered the cloud research environment creation, the public instance. We have as well the app library, which gives you a glance of the tools or the major tools that we have available here. So we have a way of filtering by the type of approach, by the type of instrument that you might be using. So if you press MS, for instance, you only see the tools that are relevant for MS data analysis. And if you click in any of these tools, you get some details about the tools. OpenMS, what is the main website, where are the sources available if needed, some descriptions, etc. So that is the app library, which showcases the different tools that we have. Then I'll go back to home. Besides the app library and the cloud research environment deployment, there's documentation available that you can access through the help button here. And here you will have documentation both for developers, but also for end users who are getting used to this new type of technology, how to obtain your credentials, for instance, but also tutorials on how to use the different workflows. So if you click in any of these, you would find instructions on how to be able to get the example data and be able to run step by step these workflows. So now I will go back to the CRE part. As you can see, we have one deployment that is starting here. We have this other deployment that I previously created for this demonstration. So I will now go to that particular instance. I will close the previous Galaxy instances that I had. So for a created deployment, I will get a Galaxy button here and this More button. The Galaxy button will take me to the Galaxy instance that is running in that PhenoMeNal Cloud Research Environment deployment. So you can see that it has this URL. This URL is essentially pointing, in this case, to a machine that is running within Amazon Web Services. As you can see, the look and feel and the experience that you get is exactly the same as in our public instance, the same tools, the same shared workflows. So I will now, to be able to use it, I will need to log in. For that, I need to retrieve my login details from the deployment part. So I go into this box where I press Galaxy and I press More now. Here it tells me that the admin email that I choose for that particular instance is this one. And I can copy the admin password to my clipboard here. And then I go to login. I input the email that I use for that, and I place the password. I can do login here. So this is a newly created instance. I think I uploaded some data previously yesterday, but and here I can show you as well how a particular workflow would look. So if I go to workflow, I have all the shared workflows that I mentioned before. I will go into Fluxomics stationary with visualization and I will press Edit. And this shows me the components of the workflow, which we explained before. And in order to be able to run this workflow, what we would need is to pair different data inputs into the inputs defined for the workflow. So as a demonstration, I could quickly run one of these workflows. So I will go into, sorry. So I won't go into the details of the workflow, but I'll just show you the mechanistic example. So this is data that we have uploaded to run on the workflow. And what I'll do now is that I will pair certain pieces of this data into the inputs of this workflow. So the first one is the exchange file, which needs to be paired to this file called ramidin. Then we have this netcdf zip file with all the raw data, and that's already paired correctly. The tracing model is to be paired there, and the SVML input is already paired with the SVML model file, constraints file, and then the map with layout for the visualization. And then once all the files are set for inputs, you can go and run the workflow. So this is telling us that the workflow has started, and as you can see now, there are some output files that will be generated, and that as the workflow runs, this will become green as the previous ones here. So because I previously ran this workflow to make things faster for this demonstration, is that I can show you the end result that you would find here, which is the fitting of the mass spectrometry data, the LCMS data, into the pathway. So you get here the fluxes values for the different reactions and the flow in the pathway. So with that, I will conclude the demonstration of the workflow environment and the portal. So the deployment is still ongoing. For more advanced users, there's this deployment log which shows some details of it, but nothing that you need to worry in general. As I said, this will normally take like 15 to 20 minutes. And it would show up here as a finished deployment that you can use, like I showed with the one that was previously deployed. Now, because I don't need this deployed instance anymore, supposing that all my jobs are run and I have taken all the data that I want to take, I can now bring down this instance that I was using. So if I go to more and I press destroy, this will take care of going to Amazon in this case and remove all the machines that we created there, so that you don't need to keep on paying for those resources. So I'll press destroy and confirm yes. And it will ask you to make sure in your cloud provider dashboard that everything has been destroyed, but we make every effort so that everything is destroyed and you don't need to worry. But nevertheless, it's good to check on your side just to avoid any unpleasant surprises later on. So with that, I'll go back to the slides. So as a conclusion, PhenoMeNal provides a scalable cloud infrastructure for metabolomics data analysis. We provide you with a point-and-click deployment, which you can very easily use, as you saw, through a web interface, which is publicly available and will allow you to deploy to different cloud providers. We provide as much documentation as possible, so that the whole task of being able to deploy to the cloud is as easy as possible for the users. The users are then presented with workflow environments in a graphical manner that can be used to interact with the different tools that have been packaged. We would be really interested in knowing if, for whatever reason, this doesn't work for you. We want to improve the resource so that it works for you, so that you can use it for your real data analysis in metabolomics. So please do talk to us if you have an interest in using, and if you have any problems in using it, whether there are tools that you need, or etc. With that, I would like to acknowledge people in the group where I work, the Metabolomics group led by Claire O'Donovan here at EBI, where you can see the people in bold there: Kenneth, Reza, Mark, Namrata, and Sigin, besides me, who are the ones who work in PhenoMeNal within EBI. And also to acknowledge all the partners in our PhenoMeNal project, scattered across Europe, and not also the partners, but as well other teams here at the EBI, like the TSI and the cloud teams, who provide very vital support for us to be able to bring this to you, and also the communities around many open source projects, on top of which we stand, like Galaxy, Kubernetes, Jupyter, Luigi, etc., which allow us to bring the product that I have shown. PhenoMeNal is funded by the European Commission's Horizon 2020 program and the grant agreement number 654241. Thank you very much for taking the time of listening and learning about our project. We have upcoming training here at the EBI, the Metabolomics Workflow course. Probably the registration for that one is gone already, but we also have the PhenoMeNal workshop right after Metabo meeting in Birmingham this December, and you should be able to access it on the URL shown there. You can find more information about upcoming EMBL-EBI webinars in the training page shown there. And with this, I will finalize, and once again, thank you for your attention and for being today here with us.